Hello, welcome to the SANGFOR Network Secure Training course. In this course, we will introduce the security protection. This course mainly includes 7 parts. Introduction to Security Protection, Intrusion Prevention, Web Application Security, APT Protection, Anti-DDoS DDoS, General Configuration, and Troubleshooting. Let's start with the first part, the background of security protection. Why do networks need security protection? Hacker attacks are everywhere. Attackers use various methods to breach devices and assets, such as exploiting system vulnerabilities to compromise devices, moving laterally across business systems, causing data leakage and system crashes, using skull injection to alter data, or embedding malware to damage the company's reputation. They may also launch traffic flood attacks to disrupt company services or websites, causing financial losses. Attackers may also steal company secrets through various means, affecting the company's competitiveness. How can enterprises achieve comprehensive protection through SANGFOR NSF? First, enterprises can implement initial security control by configuring network layer policies in NSF. For example, configure ACL policies, geo-IP blocking, connection limit control, anti-DOS, anti-DDoS protection, and ARP spoofing defense. For application layer protection, NSF can configure security policies to enable vulnerability protection, intrusion prevention, content security protection, web application protection, botnet detection, anti-ransomware, and more, to defend against deeper and harder to detect threats. In the second part, we will start introducing the intrusion prevention features of NSF. Let's first understand what IPS is. IPS stands for Intrusion Prevention System. NSF identifies attack patterns and behaviors to filter harmful data and abnormal logins. Compared to traditional firewalls that only filter data based on IP or ports, NSF's IPS detects application layer data characteristics, making it more suitable for complex network environments. Common intrusion attack methods include worm attacks, exploiting server or network device vulnerabilities, attacks through backdoors, Trojans, spyware, and other software vulnerabilities. All these attack patterns can be detected and protected by the IPS of NSF. How do we configure IPS? First, we need to configure basic network settings, such as network interfaces and network zones under the network module. Then configure ACL policies under the ACL policy module to ensure network availability for the device. After completing the basic network configuration, we need to configure the IPS templates. The templates can be adjusted for server protection, endpoint protection, brute force attack protection, malware protection, and CC attack detection. The system default template can meet most scenarios, but if customers have special requirements, we can customize the templates to fit their specific needs. After configuring the template, we need to add a new security policy under the policy module. IPS protection can be applied to protect servers as well as users. Here we take server protection as an example. When adding a new security policy, first configure the policy name, policy status, source zone, destination zone, and confirm whether it is a CDN usage scenario. In the policy configuration, check and enable intrusion prevention, select the IPS protection template we just configured, set the action to deny. Then save the policy. The IPS protection policy is now completed. After the IPS policy is configured, if there are vulnerability attacks in the network, NSF will apply the corresponding protection based on the configured policy. After the IPS policy is configured, if there are vulnerability attacks in the network, NSF will perform corresponding protection based on the configured policy. Through the security logs under the Monitor module, select Intrusion Prevention. Then choose the attack time and asset information you want to query to view the corresponding IPS logs. This image shows an IPS defense log. In the log, we can see detailed attack information, including the attacker's IP and port, the victim's IP and port, the threat level of the event, the attack type, and the original data packet from the attacker. All of these can be verified in the security logs, which helps you better analyze security incidents and trace the source of attacks. In the third section, we will learn about the Web Application Protection of NSF. Let's first understand the background of Web Application Protection. This image shows the OWASP Top 10 attacks, listing the 10 most serious security risks faced by most enterprises. As shown in the image, from 2007 to 2017, injection attacks and XSS attacks have consistently ranked at the top. These are common methods of web application attacks, so protecting web applications is especially important for overall network security. SANGFOR's Web Application Protection, also known as WAF, is mainly used to protect web servers from attacks, preventing service interruptions or hacker control. There are many types of attack methods against WAF. Here are some common WAF attack methods in enterprises for your reference. The first one is skull injection, the second is XSS attack, also known as cross-site scripting XSS, the third is Trojan attacks, and the fourth is website scanning attacks. The fifth is web shell attacks, the sixth is cross-site request forgery CSERF, which hijacks the user to perform unintended actions on a logged-in web application. There are also system command injection attacks, file inclusion attacks, directory traversal attacks, and information leakage caused by web server vulnerabilities, and so on. NSF can effectively protect against all these common web attacks. It has predefined attack types and detection rules built in. The device includes multiple attack signature databases, and NSF regularly updates these rule sets, typically on a weekly basis. In addition to basic web attack defense and detection rule sets, NSF's Web Application Protection also offers many advanced and customizable features. For example, it can hide certain applications on the web server to prevent attackers from performing malicious scans on the web applications. The hiding feature can be applied not only to FTP and HTTP protocols, but also to specific fields in the HTTP response header, such as replacing the server error page or the request error page content. In the advanced settings of NSF, there is also password protection for web applications to prevent password cracking, reduce risks and incidents caused by weak passwords, and enforce secure password management for web servers. For password protection, we can first configure weak password detection, plain text login detection, and brute force attack protection for web servers. The system has predefined weak password rules, and users can also customize them. For example, passwords shorter than 8 characters or with a complexity level less than 2 will be identified by NSF as weak passwords. NSF can also effectively protect against various types of password attacks on servers, including fast brute force attacks, slow brute force attacks, and distributed brute force attacks. Of course, you can also customize the web application password protection rules according to your specific requirements. It's important to note that for password management, NSF only performs detection and generates alerts. It does not directly block login attempts to the server. The firewall can also protect web servers by filtering incoming requests and inspecting HTTP header fields. This helps prevent hackers from sending abnormal HTTP requests to damage the server or steal sensitive information. This is mainly to prevent situations where some web servers may have inherent security vulnerabilities. In normal communication between client and server, there are two common HTTP request methods, GET and POST. However, if attackers use other request methods such as delete, move, or modify, it may cause the server to return information that can be exploited by hackers. For example, if an attacker sends a command to delete a file on the server might respond with a message like "Your operation is invalid, please try again." However, Such responses may contain system or version information about the server, which can help the attacker launch further targeted attacks against the web server. Of course, there are many other advanced features in web application protection, which can be adjusted based on the customer's actual scenario. So, how should NGFW's web application protection be configured? The configuration process can follow the steps on this page. The first step is to go to the Objects section in NSF and add a new web application protection policy template. The second step is to ensure that the template settings match the customer's scenario, such as confirming the server's port, protocol, and other relevant details. The third step is to go to the Security Policies section, create a new security policy, and apply the web application protection template we just created. Of course, we also need to select the correct network zones and IP ranges to ensure basic network availability and proper matching with the protected assets. If there is a local DNS server in the customer's scenario, it must be configured correctly to avoid logging consistencies. It is important to note that when the traffic is HTTPS, encryption must be properly configured to enable decryption of HTTPS packets. For the detailed configuration demo, you can follow these steps. First, go to the Objects module in NSF and create a new web application protection policy template with settings tailored to the customer's web application needs. Then, go to the Policies Network Security Policies section in NSF and add a new server protection policy. In this policy, reference the web application protection template you just created. In this server protection policy, we also need to configure basic network information such as IP addresses and zones, and confirm whether the customer scenario involves a CDN. Then, enable web application protection in the policy and set the action to deny. Of course, log recording should also be enabled to support traceability. Just like viewing IPS logs, go to the Security Logs under the Monitor module in NSF, select Web Application Protection Logs to view the detailed log entries. When a false positive occurs in the web application protection policy of the firewall, causing normal business traffic to be blocked, how should engineers handle it? Typically, there are two methods to handle this. Method 1. In the advanced settings of the network security policy, add URL exclusion parameters. Enter the misjudged URL parameters so that web application protection will skip detection for these parameters. This method is mainly used in scenarios where normal business requests contain special characters that are mistakenly identified by NSF as attack parameters. After excluding these false positive parameters, business testing can be performed again. Method 2. Go to the security logs in NSF, search for the corresponding blocked log, and identify the specific log entry that was falsely judged. After the rule is confirmed as a false positive by the business team, you can click Exclude to create an exception. This will disable the specific rule in the security policy, allowing the business traffic to proceed normally. In the fourth section, we will learn about APT security protection. Before discussing APT protection, we need to understand what an APT attack is. APT attacks are defined as advanced persistent threats, also known as advanced targeted attacks. This type of attack uses malware to penetrate existing security systems, then evades detection, establishes a persistent foothold inside the system, and continuously damages the target or extracts valuable data, leading to data breaches. In summary, APT attacks involve multiple steps and long-term preparation, ultimately aiming to achieve a sustained attack on business systems. APT attacks are not one-time events. They are continuous processes. It involves many steps, such as exploiting system vulnerabilities, bypassing security defenses, infecting hosts with malware to gain a foothold, cracking passwords to escalate privileges, performing network reconnaissance and lateral movement, and finally obtaining valuable information and data to complete the full APT attack chain. SANGFOR's APT protection, also known as botnet protection, works by detecting remote access Trojans on endpoints, identifying malicious URLs, and analyzing suspicious traffic to detect apt behavior and protect the endpoints. For remote access Trojans, SANGFOR has a comprehensive rule database to perform verification and detection. The detailed path to the rule database can be found in the Objects module under Threat Signature Databases in NSF. NSF also regularly updates the Remote Access Trojan Rule database. For malicious URLs, NSF detects URLs that may pose threats, such as web pages linked to Trojans or virus download links. The process for NSF to block malicious URLs is as follows. First, it checks whether the URL is in the device's whitelist. If it is in the whitelist, NSF allows the URL. If the URL is not in the whitelist, NSF will then check the system's blacklist, which is the NSF rule database. If the URL matches the blacklist, NSF will take the corresponding action. If the URL is not in the blacklist either, NSF will send the URL data to the cloud for detection. If the cloud detects that it is a malicious URL, the cloud will notify the firewall to take the appropriate action. At the same time, the malicious URL will be updated in the botnet rule database. NSF generally detects suspicious traffic in two ways. It's important to note that the device only logs the detected abnormal traffic and does not block it. The first method of traffic anomaly detection in NSF is by checking whether the port and protocol used by the service match. If the protocol used does not match a common port, it will be identified as abnormal traffic. For example, TCP port 22 is commonly used for the SH protocol. If another protocol uses port 22, it will be considered abnormal traffic. The second method is to detect abnormal outgoing traffic. NGFW APT Protection also includes auxiliary features to enhance detection effectiveness, such as detecting suspicious behaviors on endpoints to identify hosts that may have been infected with botnet malware. By default, NSF only records logs and does not directly block traffic. Of course, you can also change this action to allow NSF to block the infected host. Another auxiliary feature of APT protection is the ability to perform DNS redirection for malicious URLs, also known as DNS honeypot. This is suitable for environments where there is a DNS proxy within the internal network. When this feature is enabled, NSF intercepts DNS requests from the internal DNS server and returns a honeypot address. The DNS server then returns the honeypot address to the infected endpoint. When the infected endpoint accesses the honeypot address, NSF can accurately identify the real infected endpoint's IP. Next, let's look at how to configure APT protection in SANGFOR NSF. In the Security Policies module, create a new Endpoint Security Protection policy, then check the Botnet Protection option and select either the default or a custom botnet protection template. Set the action to deny. To view the APT protection logs, go to the Security Logs under the Monitor module, select the botnet-related logs, and you will be able to see the detailed APT protection log content. The next section, Chapter 5, covers protection against DOS and DDoS attacks. DOS attacks are a type of network attack where the attacker uses multiple protocols to flood the target with traffic, making the target server or network resources unavailable. This can result in temporary or long-term business interruption, preventing access to internet resources or blocking legitimate users from accessing the system. DOS attacks typically involve sending a large number of excessive requests to the target server, overloading the target server's system, and thereby blocking some or all legitimate requests. This is similar to a group of people blocking the entrance to a store or business, preventing legitimate customers from entering and disrupting normal operations. DDoS attacks combine multiple computers into a single attack platform. Therefore, DDoS attacks, also known as distributed denial of service attacks, target one or more victims, exponentially increasing the hacker's attack capability. At the same time, DOS attacks that spoof legitimate source IPs can also be considered a form of DDoS attack. DOS attacks are a very common type of network attack, and they can have a significant impact on business operations. For example, they can cause a company's server to become inaccessible to the internet, prevent internet users from accessing the company's internal servers, degrade network performance, or even lead to a complete network outage for the entire organization. Because these impacts cause the company's services to be unavailable or deny access, DOS and DDoS attacks are also referred to as denial of service attacks. It is important to note that, by default, SANGFOR's firewall only enables outbound anti-DOS and DDoS policies. If you need to enable inbound anti-DOS and DDoS policies, you will need to manually configure them in the policy settings. The configuration path for anti-DOS and DDoS differs from previous security protections. Since these are network-side attacks, you need to create anti-DOS and DDoS policies in the NESF's network security module. In the policy, you can also customize the DOS and DDoS attack thresholds to better align with the customer's use case, preventing unnecessary false positives. Finally, the logs for DOS attacks are also recorded under the security logs in the monitor module. By selecting DOS or DDoS attacks, you can view the detailed log content for the protection actions. We have just covered IPS, WAF, APT, and DOS or DOS protection. In Chapter 6, we will review and learn about the general configuration of security protection policies, as well as troubleshooting approaches and methods for common issues. First, for the configuration of most security protection policies, the main configuration approach consists of 5 parts. The first part is to obtain the necessary licenses and activate them to ensure that both basic and advanced features are available. The second step is to configure the basic network settings of the NSF device, such as the LAN and WAN interfaces, network zones for each interface, and appropriate routing. The third step is to ensure that the device's rule database is updated to the latest version. Regularly updating the device's security capabilities helps prevent NSF from missing detections of new types of virus threats. The fourth step is to create security policy templates based on the customer's actual scenario. If the customer does not have specific requirements, we can also use the default security templates. The final step is to create a new security policy, reference the security policy template created in the fourth step, set the action to deny, and ensure that logging is enabled. For common troubleshooting, there are mainly 2 types. The first type is when engineers configure the security protection settings, but the device does not take effect, meaning it neither intercepts traffic nor logs any actions. Our approach is to first check if the network traffic between the user and the server is passing through the firewall. If traffic is passing through normally, the next step is to check whether the firewall's bypass feature is enabled. The third step is to check if the IP is in the NESF's whitelist. Additionally, we need to check if the NESF's rule database is up to date. The fifth step is to confirm with the customer whether there is a NAT scenario in the network environment. Finally, check if the security policy is enabled and ensure that the action is set to deny. The second scenario is when the device generates a false positive for legitimate business traffic and blocks it. How should we recover and troubleshoot the issue? First, we can use NESF's troubleshooting feature to verify if the firewall is the one performing the interception. The second step is to analyze the security logs, find the corresponding blocked log, and then add the exception to the whitelist. You can configure the whitelist separately. Finally, modify the security policy template and continuously optimize the security strategy. The final chapter is an introduction to the SOC functionality. SOC stands for Security Operations Center. The Security Operations Center SOC can assess overall business risks, including risks related to devices, users, and business operations. The SOC also provides a handling guide for risk events, including risk assessment, protection, monitoring and analysis, and pending issues. SOC can manage business asset security. In the Business Asset Security module, there are summaries of security assets, attack events, and passive vulnerability scans. In this page, you can view the status of business assets and attack events, which serves to alert both customers and engineers about the assets that need focused attention and resolution. In the SOC's user security perspective, there are two modules, Overview and Attack Events. In the overview, we can see the user's security status and whether any actions have been taken on risky endpoints. We can also click the View button for a specific user's security event, which will redirect us to the user security interface to view detailed security attack information. SOC also has a specialized protection module which provides specific protection features to help engineers quickly understand threats and take appropriate action. The specialized protection functionality includes business asset management, ransomware protection, IP reputation, account protection, and endpoint app control. SOC is also where the NESP's blacklist and whitelist are configured. We can configure trusted or untrusted assets in NSF. The blacklist is primarily used to block assets globally. The whitelist is primarily used to allow assets globally. The blacklist has two modules, the permanent blocklist and the temporary blocklist. The temporary blocklist allows you to set a block duration, and once the block time expires, the IP will be automatically removed from the blocklist. Finally, SOC also has next-generation security features, which work together with the cloud, network, and endpoints for coordinated response. This helps build a complete security protection system, including risk warnings before an event, defense during the event, and remediation after the event. This includes network and cloud coordination, network and endpoint coordination, threat detection and protection, as well as security protection capabilities. The above is the content of this training. Thank you for watching. Goodbye.